Hello and welcome back. We are now moving on to week 1.2, where we're going to talk about writing methods in Java. So today's video will focus directly on creating and using Java and user-defined methods. So some of them are built-in Java methods that we've seen before. We'll learn some new ones, and then also making our own methods. It's important for us to start off by understanding the different portions of a method. So we've seen one method already. We've seen public static void main. That is a method. So methods are comprised of two different pieces. We have a signature, which is like the method header. It includes the modifier, which we'll talk more about later. That's the word public in this case. The return type, which is void, and the name of the method, which in our case is main, and then the parameters, which is in the round brackets. You'll notice I jumped over static, and we're going to learn more about static in the weeks to come. The second part of the method is the body, which is a collection of statements or commands that are called when our method is being performed. So methods are always placed within a class. We can see we have public class method test, and then we have our method inside of it. We're going to get our code up and running for today as well. So let's go ahead and get public class methods and make our methods.java file. Awesome. Oops. Print. And we can say hello world. And now we have all the different parts of our method living inside of our class. This is our main method. Oops, main method. Cool. We should make sure it works. Desktop, 1020, week 1. Is it in there? Yep, there's methods. Javax, star.java. Did that make a methods.class? It sure did. It's right there. So now I can say Java methods. Hello world. Perfect. We've got our methods program up and running. All right, let's look at these notes. So we've seen two methods. We've seen our main method, which I just went over, right, with our argument array as the parameter. We'll talk more about that later. This method automatically gets called when we run our main program. So when we type Java and then the class name, it automatically calls our main method for us. We never have to call our main method because it's a special, unique method. However, there is a method that we've seen that we've been calling, system.out.println with the brackets passing in a string. So the string parameter is what gets printed out to the console. We can ignore the system.out for right now. We're going to look at it in like a week or two. But anytime that we see those round brackets, we know that a method is being called. So the println part of this is definitely a method. When we see those round brackets, we're either defining the method or we're calling it. So, pardon me, we're going to look at two different methods, writing our own methods here and how exactly to run them. So we have one that's going to print messages, pardon me, and one that has return values. Now, it's great that this is in here, but I'm going to go ahead and just run over to the code and code it up instead. So the first one had no return type. Public, static, void, exactly the same as our main, except I called it print message. And I passed in a message, just like this. So we can see public static, we're going to void meaning no return type. This is the modifier, and for right now, we're going to keep static there until I tell you otherwise. String message. I like to think of methods kind of like packing a backpack and going on a trip. So I'm going on a trip to a place called print message, and in my backpack, I am bringing a variable called message. Now, it doesn't really matter what it's called in my main method, because in my main method, that could be in one dialect, and my print message method could be in a different dialect. And I literally am talking about dialects. Like if I were to pack a hat with me and go to France, somebody in France might say to me, that's a really nice chapeau, and that's French for hat. So of course, over here, it was called a hat, but in my method, it has a different name. That's totally fine. When I get into the method, I'm printing out something different. Print message in France. Doesn't matter. So then here, when I want to actually call the method, I can just go on a trip, call the method. just like we did with print line, only now there's no system.out. It's just print message because we are inside our own class. We can just say print message and pass in whatever message we want to print. And in this case, I'm packing my hat variable, and that's what's coming with me in here. And then inside print message, I can decide exactly what I want to print. Wow. No. Sacré bleu, right? Nope, bleu. Bleu. I don't know. That's a nice whatever hat, right? That's what's going to be coming in. It's okay that it's called message here. Perhaps I'll write chapeau, give that the variable there. Doesn't matter what we call it. The point is there is like a direct pipe from calling to the definition. So whatever I pass in, this value hat comes out on this side under whatever variable name is there, in this case chapeau. I go ahead and I run it. Sacré bleu. That's a nice hat. I don't know if I spelt that right. Sorry for anybody who's like deeply offended by my French. Okay, so this is a method that we wrote that has no return type, which means when I finish this method, when I finish running in it, when I finish basically traveling to this method, I can't bring any souvenirs back with me. Oops. So I can't bring any souvenirs back with me. Instead, I come right back up to right here, and I just continue running through my program. We can see I got hello world. That's awesome. It works perfectly, and that's totally fine. Sometimes we don't need to actually bring anything back from a method with us. Let's look at a different scenario. Let's consider a scenario where we're making a calculator application where we want to be able to add two numbers together and return their added value. Now, we don't know if we're going to enter in like small numbers or big numbers or whatever, so I'm choosing to do doubles. So I have a return type now of a double. Add nums. Double num1, double num2. Now in here, I can make a new variable, added. I can add my two numbers together, and then I can return added. So this return keyword turned purple because it's a keyword for Java, and whatever I am returning, whatever variable I'm returning, its type has to match the return type right here. So now this is different. This is like I'm going on a trip to add nums, but I'm bringing a souvenir back with me. So if I say add nums and I pack in my bag a 5 and a 10, I need to have space in my main method, like shelf space at home for the souvenir I'm bringing back. It has to be space that's big enough to hold my souvenir. Well, I know I'm bringing back a double, so I need to have a double here added together that I can now make equal to that method call. When I do this, I'm now able to say, okay, add nums gets called with a 5 and a 10. This is like a straw from the 5 that goes straight down to num1 and 10 straight down to num2. They get added together and stuck in this variable, and then I shove that variable in my backpack and I take it back home with me, and I've given it a place to live in my home back in Maine. So it's really important when we're returning that we have somewhere to return the value we're bringing back with us to. We have to actually store it somewhere. So I've declared a variable, added together, and I've assigned it the value that comes back from this method. Make sure you're still feeling good about that language. Here we can see first I print about my beautiful hat. Then I added those two numbers together and I printed their value, 15.0. Then hello world prints at the end. I'm going to take this opportunity to show one more super neat thing. Let's head over to the internet and go to a site called pythontutor.com. And I know it says Python Tutor, but we are doing Java, but that's okay because look, write code in Java, totally fine. It works. It's very happy to have us do it in Java. Actually, that was like pre-ready because I went to a different. Like if I go straight to just pythontutor.com, like here, you can see start coding online now, and then you can click Java. Okay, and then now we have this. I'm going to pick up my code that I wrote here, and I'm going to just place it in here. So it's exactly what we just did. I'm just plopping it into here instead, and I'm going to click Visualize Execution. This is really going to help us understand and see what exactly is happening in our code while we're running. So we can see the line that's about to execute and the line that just executed. Those arrows are going to move along as we go, and we can just click through each of the steps. So I'll click Next, and we'll see we made a variable hat in main. Then we'll see we made a call to print message. So we jump down to print message. And inside print message, the variable chapeau is storing the word hat. We can print it. We get sacré bleu. That's a nice hat. That's a hard word to say. Okay. And then we jump right back up. After we finished, visiting the print message method, we jump back up and continue where we left off, which will be at added together. Well, added together calls into add nums. That's going to have us jump down to the add nums method, where we're going to do that math. We add our numbers together. We get our added value of 15.0, and that is returned. We can see it just turned red, return value 15.0, and that gets brought back up into that added together variable. And now we are on line 6, where we're going to actually go and print out our added together value. There we go, 15.0. Our final line of our main method is now going to run hello world. Line 8. There's nothing there, but it still technically hits that line. It realizes it's at the end of the code, and we're done running. PythonTutor.com is a really, really wonderful way to help us visualize code execution and this sort of temporal flow, this path of execution and how our code jumps between methods. Okay, cool. I'm glad that we looked at that. So now we've seen both with a return value and without a return value, and how the code gets changed and affected appropriately. So let's just ask ourselves a quick question. Why not just put all of our statements in main? Why even bother separating out my single addition or my single print line statement, right? That's so silly. Well, you're right in saying you could put all of your statements in main, but just because you can do something doesn't mean you should. You should kind of think about the main method like the CEO of a company that doesn't do any low-level work, right? Main delegates its work to lower-level workers who can possibly even delegate work further. For example, if we look at this code right here that we wrote, main delegates work to print message. Print message delegates work to print line, and then print line under the Java hood does what it needs to do to actually print out our information. So delegation is already happening all of the time. We really want to make sure we ask ourselves, what is our code doing? Every single behavior should have a function that possibly have more managers and middle managers, etc., calling the shots, organizing the code, making the commands. That's one way to sort of tell us what exactly should exist in terms of methods. Another good indicator is duplication. If we find ourselves copying and pasting code a lot, that's usually a really good indicator that we need to make a method out of that instead. Anytime you find yourself copying and pasting code, you need to stop and ask yourself, is this a behavior that should be a function, that should be a method? Function and method are relatively interchangeable. You may hear me use one over the other. Method is preferred for Java code. Function is preferred for for Python and C code. But they mean the same thing. They mean a subroutine, a routine that you've segmented off in one way or another. Okay. Let's look at this example here. I've made a program that takes in 2 positive integers, and they are in Celsius. Doesn't matter what they are. I put question marks. Doesn't matter. It should then convert those temperatures to Fahrenheit and then figure out the average temperature and print their value. And if I was let's just put all my statements in main, this is what that program would look like. Celsius 1, Celsius 2, 2 Fahrenheit calculations, an average, 2 print line statements, and then an average print statement. We can see a little bit of code duplication here. We can see some calculation duplication here. We can even see some of the print line statements have duplication here. So while there are subtle differences, like the variable changing, for both the calculations and the print lines. That's the only thing that changes, the variable. And if it's the variable that changes, that can always be passed in as a parameter. So if the only difference between your copy-pasted lines is your variables, you definitely should be making a method instead. So let's look at that. There we go. Okay, so here's slightly better. Let's take a look and see what I've done. I've gone ahead and I've created a method convert to Fahrenheit. And this convert to Fahrenheit method takes in the Celsius value and returns a double value of the Fahrenheit value. So that is now being called twice here, one for each of my Fahrenheit values. Perfect. Then I can calculate my average, and I've made a print convert method which goes and passes in the Celsius and Fahrenheit values, and we can see once again here that that gets called twice over here. Oops, that gets called twice over here, one for each of our values, and then we can print out our average. Okay, this is a lot better already, and this in this course, even in the real world, would be like considerably better, possibly even considered acceptable. However, we're going to take it one step further. If we want to consider our main method like a CEO, it should not be doing any of the low-level work at all. It should just be barking the commands. It should not be doing any of the printing. It should not be doing the get average calls. There's still too much happening here. The CEO should be taking in the information and then handing it out to the people it needs to go to. So let's look at one more example here that's one step further. Here we get all of our main, our CEO takes in its Celsius values, it passes those values into the convert to Fahrenheit, and then it takes those Fahrenheit values and passes them into another method to take care of all the printing. We're just passing off that information. Print Fahrenheit passes that information as a middle manager to print convert. So print convert still exists twice, still has to exist twice. However, the actual printing of it happens much lower down. And this way, if we do need to change the wording or something like that, we're only changing it in one place. Print convert runs twice, no problem. Same with the Fahrenheit calls, right? Those are still in a separate method. If the method ever changes, right, if the calculation from Celsius to Fahrenheit were to ever change, it won't, but if it ever were to, we're just changing it in one place in our code. And now our main CEO, our main method, is not really doing any work at all. It's just barking out commands. It's just saying, these are the things I need you to go and do. And this is the best way to structure our code. It's very, very intuitive. It's easy to read. It's a little bit harder for us to follow when it comes to following it with our finger because we're jumping around to different methods. But we can use Python Tutor as a way to sort of see what that jumping around looks like if we need to. All right. So I have a pause and practice here as well, where you're going to create a basic calculator that can perform the 4 fundamental arithmetic operations. That's adding, subtracting, multiplying, and dividing. And you're going to focus solely on writing methods with appropriate return types. Okay, so you're going to imagine you have 2 integer variables in main with values 8 and 17, which you can just hard code. So if we go back to what I had here, where I had double Celsius 1 equals question mark, double Celsius 2 equals question mark, you're going to have int value 1 equals 8, int value 2 equals 17. Okay, you're just going to hard code those values into your main method, and then you are going to go ahead and write your code so that your output will clearly display the operation being performed and the result. So here's an example. I've got operation addition. Output format would say the first number, so 8 plus 17 equals the result, where the first number would have been 8, right? So that's value 1. Second number is 17, and then the equal sign, and then whatever the output would have been, whatever came back from that method. So do this for each of the 4 operations, get them all to print out nicely, and if you'd like to see an example solution, I did post one, basiccalculator.java. I don't recommend looking at the solution until after you've tried it. Reading a solution is not a way to learn anything in this course. I always hesitate to post solutions because students will go and read it and say, oh yeah, I know what she's doing, and then count that as having learned something. That is not the same thing as trying it for yourself. So please try it for yourself first and see how that goes, and then you can go ahead and look at the solution and sort of see, where you went wrong and where things maybe need a